This video is sponsored by Brilliant. More about them at the end of the video. Here is an interesting Olympiad math problem about selecting a hockey team. Let's start with some basic information. The team must consist of 6 players. There are players who can play only in one position, and there are players who can play in multiple positions. Universal players add flexibility but require careful allocation between defense and offense, but not as a goalkeeper. Selecting hockey team requires choosing 6 players, 1 goalkeeper, 2 defenders, and 3 forwards. Available candidates include 3 goalkeepers, 5 defenders, 6 forwards, and 3 versatile universal players who can play defense or offense. Calculate the total number of valid team combinations possible under these constraints. Let's start with the first step. We have 3 goalkeepers available, and we need to select exactly 1. This is a combination problem, specifically a combination of 1 from 3. A combination of 1 from 3 equals 3, meaning there are 3 possible ways to select our goalkeeper. This selection is independent of the other choices we'll make. Step 2. Choosing defenders and forwards. The challenge comes from the fact that universal players can serve as either defenders or forwards. Because of this dual role, we must break the problem into separate cases based on how many universal players we use in the defender positions. Case 1. Both defenders are selected from the dedicated pool of 5 defenders. Case 2. 1 defender comes from the 5 dedicated defenders and 1 from the 3 universal players. Case 3. Both defenders are chosen from the 3 universal players. Case 1. Both defenders from designated defenders. Right 5 choose 2. This represents choosing 2 defenders from the 5 available. We calculate this as follows. Multiply 5 by 4, then divide by 2. That gives us 10. So there are 10 ways to choose the 2 defenders. Since no universal players are used here, all 3 universal players remain available for the forward positions. Therefore, the pool for forwards now consists of the 6 dedicated forwards plus the 3 universals, totaling 9 players. Next, we need to choose 3 forwards from these 9 players. Now multiply the number of defender selections, 10, by the forward selections, 84. 10 times 84 equals 840. Case 2. 1 defender from designated defenders and 1 from universal players. Right 5 choose 1 times 3 choose 1. First, choose 1 defender from the 5 dedicated ones. 5 choose 1 equals 5. Next, choose 1 universal player from 3. 3 choose 1 equals 3. Multiplying these together, 5 times 3 equals 15. However, because 1 universal player is now used as a defender, only 2 universal players remain available for the forwards. The forward pool now is composed of the 6 dedicated forwards plus these 2 universals, making a total of 8 players. Now we choose 3 forwards from these 8 candidates. Case 3. Both defenders from universal players. For this case, write 3 choose 2. This means we select 2 defenders from the 3 universal players. With 2 universal players now used as defenders, only 1 universal remains for the forward positions. Therefore, the forward pool consists of the 6 dedicated forwards plus 1 universal, making 7 players in total. Multiply the defender choices, 3, by the forward choices, 35. 3 times 35 equals 105. Step 3. Combining all cases. Since the cases are mutually exclusive, we add the number of possibilities from each case. Add 840 from case 1 plus 840 from case 2 plus 105 from case 3. Step 4. Incorporating the goalkeeper selection. Remember, we already had 3 ways to choose the goalkeeper. Since the goalkeeper selection is independent of our defender and forward selections, we apply the multiplication principle. Multiplying 3 goalkeeper selections by our 1,785 defender-forward combinations yields 5,355 possibilities. Key concepts. Recap. A combination of R from N items calculates the number of ways to select R items from N options, where order doesn't matter. The multiplication principle states that for independent events, we multiply their individual possibilities to find the total number of outcomes. The addition principle allows us to sum the possibilities from mutually exclusive and exhaustive cases. This systematic case-by-case analysis, combined with proper application of counting principles, helps us solve complex combinatorial problems while ensuring no possibilities are missed or counted twice. Ever felt like math is just a bunch of confusing formulas? It doesn't have to be. You can actually get it, see the patterns, understand the logic, and even enjoy learning it by doing. That's why you need to check out today's sponsor, Brilliant. Forget boring lectures. Brilliant makes learning interactive and fun. You solve puzzles, explore ideas, and actually understand math, AI, and coding by doing, not memorizing. And it's for everyone, whether you have children who are struggling with school, math, a parent brushing up on skills, or an adult looking to break into IT, AI, or data science. Brilliant's step-by-step lessons take you from the basics all the way to advanced topics like machine learning and neural networks. No prior experience needed. Best part? You get a 30-day free trial to check what Brilliant can offer you. Visit brilliant.com/MyDailyMath or use the link in the description below, or just pause the video and scan QR code. Use the link to also get a 20% off an annual premium subscription. Try it today. Huge thanks to Brilliant for sponsoring this video.